So in this video, I'm just gonna explain derivative exponential functions. So what I'm gonna do is remind you what derivative means. If I have dx of ln x, then I get 1 over x. And if I have dx of ax to the n, then that's an multiplied by x to the power n minus 1. So that's just basic stuff you must know. And from then, I'm going to quickly remind you of the logarithmic rules. If I have ln a to the power of b, then this is the same as b multiplied by ln of a. So basically this is just, and if I have ln a multiplied by b, this is the same as ln a plus ln b. If I have ln a divided by b, then this is the same as ln a minus ln b. So that's just the basic stuff you must know. But now what if I want to derive some function e to the power f of x, where this is a Euler's number, 2.7. Then what I'm going to do is that I'm going to say ln y is equals to ln of e to the power of f of x. Then what I'm going to do is just I'm going to apply this. So the f of x, it comes here, and I have ln of e. But then I know that ln of e is 1. Then 1 times f, that's just going to be f. So I have ln y equals f of x. So what I'm going to do now is I'm going to derivate. I'm going to say d over dx of ln y. This is the same as d over dx of f of x. But then what's d over dx of f of x? That's just the derivative of f of x. It's f prime of x. And here I'll have 1 over y. Then obviously I have to multiply that by dy over dx. Then that means that dy over dx, if I just multiply both sides by x, by y, multiply both sides by y, then I'm going to have y multiplied by f prime of x. But then what's y? Y is e to the power f of x. Then I have this, so I'm just going to take it there, f prime of x. What this means is that if I'm deriving e to the power f of x, then if I'm deriving e to the power f of x, then I'll have e to the power f of x times f prime of x. So basically I can use this formula to say that if I'm deriving e to the power of 2x, d over dx of e to the power 2x, then I'm just going to say it's e to the power 2x, then I multiply by the derivative of 2x, which is just 2. If I have e to the power of x, I'm finding dx of that, then that's e to the power of x, the derivative of x is 1, so we're just going to multiply by 1, which is the same as e to the power of x. Any number times 1 is that number. If I have e to the power x squared minus 6x, from then I know that I can just find in dx of that. Then from this you can just say it's e to the power x squared minus 6x multiplied by the derivative of x squared minus 6x, which is just going to be 2x minus 6. So that's how you can work out these problems, only if it's e. But some problems you cannot have e. Say for example 5 to the power of f of x. Let's say you want to derive something like this. Other cases include dx of x multiplied by e to the power of 2x. From this you must apply the product rule. The product rule says that we differentiate x, then we multiply by e to the power of 2x, then we're going to add x, then we multiply that by the derivative of e to the power of 2x. That just means prime, by the way. This just means prime. The derivative of x is 1, so I have 1 multiplied by e to the power of 2x plus x, and the derivative of e to the power of 2x is just going to be e to the power of 2x multiplied by the derivative of 2x, which is 2. Then notice now I have a factor, e to the power of 2x. And from then I can just say it's e to the power of 2x. And here I'll be left with 1. I have addition sign. And here I'll be left with x and 2. X times 2, which is 2x. So that's just basically how you can apply this. That's how you can apply this. But now say you want to derive something like dx of e to the power of x minus 1 divided by e to the power of x plus 1. Let's say you want to derive something like this. Well, I can just easily say that when I use the quotient rule here. So when I use the quotient rule, I know that the answer is going to be e to the power of x minus 1. I have to derivate that, and I have to multiply by the denominator, which is e to the power of x plus 1. And then I'm going to subtract e to the power of x minus 1 multiplied by the derivative of e to the power of x plus 1. I have to derivate that. Then I'm going to divide by e to the power of x plus 1 squared. So in a sense, I'm going to have e to the power of x plus 1 squared. Then the derivative of e to the power of x, it's e to the power of x. The derivative of negative 1, it's 1. So I'll just have e to the power of f of x. E to the power x, multiplied by e to the power of x plus 1. And then subtract e to the power of x minus 1. Multiplied by the derivative of e to the power of x plus 1. The derivative of e to the power of x is just e to the power of x. The derivative of 1 is 0, since 1 is a constant. So now I'm going to have something like this. So e to the power of x times e to the power of x is just going to be e to the power of 2x. And e to the power of x times 1 is just going to be e to the power of x minus e to the power of x times e to the power of x, it's e to the power of 2x. Negative 1 times e to the power of x is minus e to the power of x, of which I have another negative here. Negative times negative is positive. Then I'll have something like this, divided by e to the power of x plus 1 squared. Then this cancels with this. Notice that this cancels with this. So I'll just be left with e to the power of x and e to the power of x, which is 2 e to the power of x divided by e to the power of x plus 1 squared. So that's just basically working with e. But now what about the cases like this, where the number is no longer e? Remember, this formula is only applicable if it's e. But now we no longer have e, but we have 5 to the power of x. Stick around for a new derivation, of which we can derivate a to the power of f of x, where a is some number. Stick around.